Alright guys, welcome to this new video, and in this one we want to talk about channel packing and especially how you can use this in material creation. But I also wanted to show you how you can pack your different texture channels like metalness, roughness, ambient occlusion into one color image and use this, for example, in Unreal Engine and such. So maybe let's start with the technical details, but I don't want to go too deep into this. So just an overview. So channel packing describes the process of composing multiple grayscale images into separate color channels in the RGB space. And I think the only necessary thing that you need to understand here is that when we are working in RGB space, one image consists of red, green, blue and an alpha. And there's no actual color stored in the separated channels, but rather an intensity value. So for example, when we have this image here, it's quite green, and the reason here is that in the green channel we have a brighter grayscale value than in the other channels. So for example, when I bump this up to white and decrease those to black, we get a full green image or full green color. And when we mix in red, you can see when we add intensity, the color changes and we are getting a yellow color. Then when we add more blue, we get white, a white output. And for example, when we reduce the green, we get a purple output. And let's just check what happens when we have blue and green, we get teal. And just red and blue, we get a purple color. And as you can already see, when we split it again, we have exactly the same outputs in the separated channels as we inputted it initially. And we can make good use of that. So let's go to the second example and take a look at how we can use this in material creation. So in this case, I start with this Voronoi shape here, and those are just the outlines, or the cracks. And let's say you want to make some rocks from that. You won't only need the outlines here, but maybe you want to have some height difference. So you have so you process this through the flood fill node and use a flood filter color. And this adds a different grayscale value to each of the cells. Maybe we want to have some slope variance, so we use the flood filter gradient and have this nice slope variance here. And when we just blend it like this and use an average blend, you can see that this fits perfectly because we didn't process this yet. But when we use a warp, for example, and Perlin noise, maybe let's set this to 4, use this as the gradient input. And let's bump up the intensity. Then maybe you want to have some chiseled up edges. So we use a slope blur node and a turbulent Perlin noise. Let's set this to minimum. And then we maybe want to directional warp this as well with a clouds heavy noise. Let's set this to 4 directions and also just a slight value here. And when we now want to blend this over the flood filter color, you can see that this doesn't really fit anymore. So when we would blend this, this wouldn't look correct. And what we'd have to do, we would need to use all of those nodes, process this through it, and then do the blend. And then it fits perfectly again. And we would need to do the same with this. And now this also fits. And as you can see, we needed to use many nodes to achieve this result, and we didn't even process the alpha here. So to save some nodes, processing time, and have a cleaner graph, let's just delete that. We could now go in and use the channel compose node as in the other example and input those into our red channel, this into the green channel, this into the blue channel. Let's maybe even use the alpha here. And now we can just warp this with the Perlin noise and slope blur it like we had in the other example. Let's also set this to minimum. And let's directional warp this as well. Also in 4 directions as we had it. So now we processed all of those inputs with just 4 nodes instead of, I think we had 12. And now we can go in and channel split those. And when I use the assign image node, we can assign all those channels to a node. And as you can see, all of those got processed in the same manner as the initial input. And we just used 4 nodes or 5 with this channel split node instead of 12. And of course, we have our alpha as well. So let's assign that. Yeah, now we can start to do with those whatever we want or need to do. And this is just one example, but I think this is the example that I use channel packing the most for in material creation. So for the next one, let's take a look at channel packing different material channels, as mentioned, metalness, roughness, ambient occlusion and such. So in this example, I already have a packed texture, and maybe let's preview this first. So we have an ambient occlusion map here, a roughness map and a metalness. Also the metalness is fully black, so doesn't really count. But when we go to channel split, and again, let's assign those. So this is fully black, and this is our roughness, and this is our metalness, and this is our ambient occlusion. And as you can already see, this really helps to reduce the number of textures that we need to import in our game engine. But it also helps to improve performance and optimizes the memory usage. And this will be just a quick one. So in general, what you need to do to have such a packed texture, let's maybe use a material. This is from this one, I think. As you can see, this is quite a normal PBR material with separated channel. Here's the roughness, metalness, AO, and all the other channels. And when we want to export this as packed, let's just go to the export window. And as you can see, I already created a template and called it channel packed. Let's start from scratch. Let's delete that. And let's go to no template. So this is how it usually looks like, the export window. And when you would now export, you see that you would have all the separate images or textures as usual. But we can create our template and merge those, all the channels we would like, into one texture or one color image. So let's just go to add template. Let's call this packed or packed channels. Let's press OK. And as you can see, as soon as we do this, we have one color output and one grayscale output. And as this is just for channel packing, let's just delete this. So the color output gives us the red, green, blue channel and the alpha channel. And all we basically need to do is just now go here and drag and drop, for example, roughness into red, metalness into green, and ambient occlusion into blue. And when we call this occlusion, roughness, metalness, you can see it shows here in the export template. And we would expose those maps, and all of them would export in just one color texture. So it's quite simple, but also quite powerful. In general, those output templates are really awesome, and I'll probably make a separate video on this soon. But I think that's it for now, so thanks for watching, and if you have any questions, just let me know, and see you soon.